We typically control aggregate production by measuring finished gradations. This is a reactive approach to process control with no specific feedback as to where to investigate when there is a problem. When you are investigating failed gradations, you must look at reduction, screening, and washing. Evaluating screening is challenging because an individual screen deck can affect multiple aggregate products. I want to discuss an alternate, proactive approach for performing quality control on aggregate screening, where we directly monitor the consistency of each screen deck. In this Leveraging Lastrada video, I'll demonstrate Lastrada's oversized and undersized approach to directly monitor screen deck performance. This approach directs your attention to a specific screen deck before any of the potentially affected products fail specifications. Lastrada users will find the template used in this video in the Customer Resource Center. Non-Lastrada users can download an Excel version of the same report on our website. Let's review this basic aggregate screen deck diagram to understand the concepts of oversize and undersize in Lastrada. You will see similar screen decks in aggregate production facilities and in asphalt batch plants. This example screen deck sorts aggregate into 4 size fractions. If I look at the second product in this screen deck, the oversize is the aggregate size in the sieve set that indicates the consistency of the screen above. We track the percent retained of the oversize and therefore monitor the amount of material we expect to be passed or retained the above screen deck. The undersize is the sieve that indicates the consistency of the deck below. We track the percent passing of the undersize and therefore monitor the amount of material passing this product or retained into the product below. Some would call undersize carryover. In Lastrada, you define a product's oversize and its undersize in the aggregate product production specification. The relationship or order of products in the screen deck is defined by the output index of a product list in Lastrada. If you are using our Excel tool, the output index, oversize, and undersize are selections in the spreadsheet. Let's look at some plant data. This data is from a currently producing aggregate plant. I will start by filtering in data from the screen deck product list and running a standard gradation report that shows cumulative percent passing and control charts of the same data. When you review the data, you can see the 3/4 inch product is running coarse on the 3/4 inch and 1/2 inch screen during this period of time right here. The 1/2 inch sieve is also coarse during that same period of time on the 1/2 inch and the 3/8 inch sieves. The 3/8 inch product appears to be unaffected during this period of time, and if anything, it might be running a little more fine on its coarse aggregate sizes. Let's now run the screen efficiency report on the same data. This page of the screen deck consistency report provides a basic overview of both the oversize and undersize of each of the products on this screen deck, some basic statistics, means, standard deviations, minimum, maximum, and range of both the oversize and undersize of each product. I'm going to move to the next page of this report where we graphically look at the oversize results together. This is the period of time where we had identified both the 3/4 inch and 1/2 inch crushed materials as being coarse. And we can see their oversize trends are both trending up. So we have more oversize in these products during that period of time. But when we look at the 3/8 crushed and the rock dust during that same period of time, we can see that they actually have less oversized material or coarse material in their products during that same period of time. When we see an increase in oversize on this product and the second product, and a corresponding decrease on the third and fourth products, the most likely root cause of this change is reduction or crushing. If I had to guess, I would suspect that during this period of time, the crusher itself was not choke fed and was yielding a slightly coarser product over the screens to be sized. Now let's go look at excess fines or carryover. I'm going to go back to the statistics report we were looking at earlier and blow it up a bit. So let's look first at the 3/8 inch product. Now we can see the fines portion of the 3/8 inch products during this period of time is getting coarse. If we go through and we look at the product below, the manufactured fines, we see the same behavior here in the number 8, 16, 50, and 100 sieves. Let's go look at the undersized portion of our report and see what that tells us. We see in this undersized report the amount of undersized or fine material in both the 3/8 crushed and the rock dust is decreasing during this period of time, which we knew and we saw in the gradation results. But what we also see during that same period of time is an increase in undersized material in the 1/2 inch crushed product. What that indicates to us is that this screen, the undersized screen of the 1/2 inch, is blinding over, and the fine material that we would expect to see in the 3/8 and rock dust is being retained here in the 1/2 inch material. Since we're talking about blinding over, we would recommend you also add moisture content data to these reports. Unfortunately, our example dataset did not include moisture content data, and it is not included in this video. This example, again, was used from an aggregate production facility dataset. The same technique is applicable to asphalt batch plants. Thank you for watching. For more tips like this one, check out our other Leveraging Lastrada videos at lastradapartners.com/resources. Lastrada Partners employs registered professional engineers and industry veterans to help you solve problems such as this one. You can schedule a free consultation with one of our engineers by going to our contact page. Thank you.